So, Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everybody. So, we have to change our classes to the morning today because I have to present my research work in Universitas Pajajaran in this afternoon. So, it's quite rushing if I try to do both jobs at the same time. So, for today, we will continue our discussions regarding discussion about chapter 1, which is structure and bonding. Yesterday, we already discussed a few questions regarding the resonance, geometries, of course, and also most of them coming from resonance geometries and also hybridizations. So we continue with a few set of questions. I guess I give you around, I'm not sure how many questions, but for me, I have around 9 slides. I think we can have a short classes for today. So for these questions is question number 1. So I will okay. It's a draw all possible isomers for this draw all possible isomers for this molecular formula C3H6O, and actually you have to try and error by following the octet rules. You have to bear in mind oxygen can make 2 bonds together with 2 Lewis 2 pair of electrons. Carbon can make 4 bonds, hydrogen can make 1 bond, and nitrogen can make 3 bonds with 1 pair of electrons. So you should try and error. This is the answer for this kind of questions. Okay, yeah. And this is the answer for these possible isomers. They have 6 isomers, but the easiest way what you can do is try and errors to make sure this is not a similar compound. So this is the ketone. Okay, what is that? This is ketone. And this is aldehyde. Sorry, this is aldehyde. And this is the ketone. And this is a alkene with OH functional groups. Okay. And this is also alkene with OH functional group, but different is position of OH. And together with this one. And this is kind of ether, okay, but with oxygens in the systems, not at the branch. And this is oxyrene. Okay, with OH functional groups here. And this is kind of compounds. And lastly, this is the also the oxyrene ring. Okay, I hope you managed to draw 9 of the isomers. Okay, if during the finals, if this question come out, probably 1 compound is represent 1 marks, and if they have 9 isomer, is 9 marks. Okay. Okay. Any question for the isomers? First, you have to understand what is definition of isomers. Okay, the isomers have different arrangements in atoms, and also it's not similar with another compounds. Okay, and also different arrangement of electron and so bonding. It's different with the resonance structures. Resonance structures is the same arrangement of atom, but different arrangement of electron or bond. Okay, Next, okay, draw the resonance structure and resonance hybrids for compound below, okay, which contribute less. Okay, we have this kind of neutral compounds, but I don't like this kind of questions because you have to make the compound into ions. So, but this is the best example that I can show you what is the more contributor or less contributor of hybrid compounds, resonance compounds. There's a lot of people coming in. Okay, so how you can do that? Okay, so you have to understand a good resonance structure is the one that has more bond, fewer charge, or less charge, or neutral. Okay, the better structure is a major contributor. This is quite important, and the minor contributors, okay, is the not really good structures. Okay, and in this case, what you can do, okay, for example, like this, they actually force this to going up. Okay, that's why in my opinion, this is not really good examples, because to force any pi bond or any electron, pi bond especially, okay, we need something to force them to move. Okay, but in this case, it doesn't have any force to move the pi bond to go to oxygens. This is for me is not really good examples. And in this case, okay, this is the first resonance structures. Okay, oh my god, this is the first resonance structures, and in this case, okay, they have 3 CO bonds. Okay, 1, 2, and 3. Okay, no charge contribute the most. Okay, the first one, the first resonance. When we move the pi bond to these positions, it's become 2 CO bond, okay, 2 CO bonds, and this case is become 2 charges, 1 charge in the oxygens, another charge in the carbons. How to know the charge? Yesterday I received a more personal WhatsApp. How to know the charge? You have to calculate the formal charge. Okay, this is only way how you can know the charge. Okay, calculate the formal charge.
Doctor. Which one is resonance hybrid?
This is not yet the resonance hybrids. This is only the resonance structures. Wait, this one. Let me finish the last one. Okay, the last one. Okay, you realize that the below oxygens have a pair of electrons also, so you can easily move to the oxygens, the second oxygen pair. So in this case, you have 3 C bond, but in this case is 2 charges. Okay, 2 charge and 3 CO bonds. Okay. In terms of this definition, a better resonance structure is the one that has more bond in and fewer charge. So the better structure of we call major contributor. In this case, okay, this one is the major contributor. Okay, this one is minor contributor. And this one also a minor contributor. If we draw 1, 2, 3, and we have to arrange from more stable to the less stable, so you can do this 1, 2, 3, or 1, 2, 3, stable, or 1, 3, 2, 1. More stable. Okay, we have Megan here.
Doctor,
Yes, who is that?
mechanics. Isn't 3 more stable than 2? Because 3 still has a double bond.
Yes. But this question only asks about minor and major contributors. So this one, number 1 is major contributor, number 2 and 3 is minor contributor. Oh, sorry. 1, 3, and 2. Sorry.
Okay, thank you.
1, 2, 3, and 1. Yes, sorry. Okay. Any questions?
Doctor.
Yes. Wait. I have to admit one person to come in. Okay. Who's that?
Dr. Eddie.
Phoenix. Eddie. Yes.
Would you mind share your slide again, because there's a few students cannot see your slide.
I already share my slide.
Oh, because in the box chat, one of the student, which is Mahida, cannot see your slide.
Ah, really?
Yeah.
We start again. Share again. Can we see the slide now?
For me, it's cancer.
Thank you.
Yes, sir. Thank you, sir.
Thank you, Eddie.
Doctor, thank you.
Because sometimes I get distracted because some people coming and help. So, Adini, is it okay? Yes, perfect. Mahida, yes, okay. Dimitri, you can see that one? Okay.
Yes.
Okay, next go to the next questions, okay?
Better.
Wait, attends. I think my computer is hang now. Okay, yes. Oh, okay. Okay, next questions. Draw all the resonance structures for each species. They have 2 species here. So there is one student asked me how we want to know how many resonance structures. Okay, first in general you have to try and errors. Okay, by following the same rules that we learned before. Okay, the second one, if the question give you 5 marks, it means they have 5 resonance structures. There is only keywords there. Okay, right now they have no half mark for one structures. No, one mark for one correct structures. Okay, this is the only way how we can know how many resonance structures. Okay. I didn't leave the meeting. Okay. I don't know. Okay, next, let's go to the next questions. Okay, draw all the resonance structures for each species. Okay, so what you can do is, okay, just move an electrons here. Okay, 5 bond here, so you can get the second structures. Maintain this one because you already interrupt these systems. So you move is already here. Okay, the plus charge will be in these positions. Okay. First one. And I have another possibilities that you can do is the possibilities that you can do is you can move here. So on. For the same services. Okay. Okay. Okay, there's only 2. Okay, in this case, no adenine coming back. Okay. Adenine, do you see the slide?
Doctor,
Yes.
isn't we supposed to move it anti-clockwise?
Anti-clockwise cannot.
No, cannot.
Yeah, if you want to move the anti-clockwise way, yeah, some people joining quite late, so I have to allow them to enter. Okay, let's do anti-clockwise. Okay. Oh my God. Let's do anti-clockwise. Okay. Okay. So tell me, which one need to move to force this positive charge to move also? Okay. When you try to move the sigma bond, it's almost impossible because the sigma bond is strong bond. So as I said before, there is only 2 that you can move, the charge and also the pi bond. So there is only way you can move it here. So it's become like this. See? And again, you have to calculate the formal charge. Okay, this deposit should be here. Okay. Okay, who is ask me the question that one?
Oh, okay.
Okay, nice, perfect. Okay.
Yeah.
Okay, welcome. So next, go to question B. So easy. So you have to move it here. So formal charge is here. And again, you have to bear in mind that oxygens have 2 electrons. So you can give it here. So, okay, in this case, it's like this. Okay. Okay. Yes, correct, Elson's. Okay. Please read the Elson's opinion. I think the point is to move depending on the way the electron is let off. Yes, meaning if there's a positive or the pi bond should move forward. Yes, correct. Okay. Okay, any question for the resonance? I realize we do more exercise on resonance because I just want to make everybody understand about the resonance structures. For hybridizations and geometry, I think it's quite simple for you because it's quite direct. You see 2 groups is linear, 3 groups is planar, right? And I think if you have 4 groups, they have 3 types of geometries: tetrahedrals, base shape, and trigonal pyramids. So there's only 5. Okay. In organic chemistry, they have 5 only. If you learn about inorganic chemistry, it could be more. Okay. Bipyramidals, for example. Okay. Okay, next. Okay, draw the resonance structure for each ion, then draw the resonance.
Good morning, doctor.
Who is that?
Eating.
Eating, okay.
Doctor, can I know for the resonant hybrid for question 6?
Okay. Resonance hybrid for question 6. Okay, let me find it. Okay, this is the resonance hybrid. So you see where is the charge now. So we have one charge here. It should be delta negative. One charge here should be delta positive. Sorry, I don't realize that the questions. And lastly, this is another charge here. Should be delta positive. So okay. I hope I answering your question. Eating?
Okay, thank you, doctor.
Welcome. Sorry, I don't realize these questions. Okay, next. Okay, draw the resonance structure for each ion, then draw the resonance hybrid. So you have to draw all the resonance structures. And lastly, draw the resonance hybrids. So, okay, this is the first one. What you can do is just move pair of electron. If you confuse, just draw, just doing like a Lewis acids. Okay, draw the pair of electron here. 1, 2, 3, like this. And after that, move it an electron here. Carbon have to follow the octet rules. Put it up. Okay, so for the first structure, move to the second structures. Okay, and this is the resonance hybrid. Okay, because this is delta negative, delta negative also. This is the localizations of movement of bond. Okay. It's mean double bond can be in 2 locations. So next, D. Again, you have an extra. To make sure you're not confused, you have an extra electron here. Okay, again, you have this movement, which is 2 arrows. Okay, and again, for the hybrid structures, refer again back the electron and put it partial negative here. This is delta negative and delta negative for hybrid structures. And of course, double bond can be moved in 2 locations here. Okay, lastly, okay. To make sure everybody understands and doesn't want to make confused, so put a shared electron here. So you can move it here. This one is become positive. So again, this is kind of simple question, simple examples. You can transform one compound to another compound by using a resonance. Okay, this is the resonance hybrid for this kind of compounds. Okay, nice. All about hybrids, don't worry. Okay, lastly, okay, this kind of compound, okay, trade name to use in Parkinson disease, which contain L-dopa, carbidopa, and entacapones. Draw the resonance structure that is equal contributor of to the resonance hybrids. Okay, understand carefully the questions. And the second one, draw the resonance structure that is a minor contributor for resonance hybrid. First, equal contributor. Second one is minor contributor. Okay. Okay, equal contributor is easy. Okay, equal contributor. So what we know about we need to put. It's depend on you. It's okay. Because only chapter 1 you playing around with electron, with lone pair. The next previous we will use the skeletal structures. Okay, don't worry, Hidayah. Okay, if we refer this first question, they ask about the equal contributors. Okay, so the answer is only once, just playing around the movement of electron in the benzene ring. So first resonance structure, and you will get the resonance structure. Equal contributor is mean doesn't much change. Okay, doesn't increase any number of bond formations or increasing charge. Okay, all electronic conformations about this compound is similar. Okay, for the two, draw the resonance structures that have a minor contributor to resonance fibrates. Okay. Okay, this compound is neutral, and this compound has charge. Okay, major contributor is more bond, less charge. Minor contributor, vice versa. Okay, so in this case, we have a neutral contributors, neutral compounds, and this one is cations. Okay, in cations. So in this case, they have two charge here. Okay, so just move a pair of electron here to this bond. Okay, and lastly, you have to make sure carbon follow the octet rules, and you have to force the pi bond to go to the oxygen. So you will get from A structures to the B structures. Simple as that. Okay. Okay, next. Oh, finish. Okay. Any question for this chapter 1? And I guess next week we will go to chapter 2. Okay. I just want to make conclusions a little bit before we finish chapter 1. In this chapter 1, we will cover, okay, the first one is the most important thing that you have to understand is the resonance structures. Okay, what is the resonance structures? What is the resonance hybrids? What is the major contributor? What is the minor contributors? Make sure you know how to calculate, how to draw the resonance structure and resonance hybrid. What's next? It's also involved the calculation of formal charge. Okay. You have to know what is the difference between isomers and also resonance. And we go in advance about the hybridizations. They have 3 hybridizations because it's on inorganic only. Okay, sp3, sp2, and sp, or sometimes they call sp1. Okay, sp is linear in geometries. sp2 is tetrahedral. Okay, and sp3 they have 3 geometries: tetrahedral, trigonal pyramidals, and also bend shape. Okay. Okay, any question for this chapter 1? Are you satisfied?
Sorry, sir.
Yes, who? Chan Ji Ning. Yes.
Yeah. The first question, question 5.
5.
The isomers.
Okay.
Yeah, this. Can I include the geometrical isomerism?
No. Isomer, positional isomer only. Not geometrical. Because it's chapter 1 only. Okay. If we go chapter 5, it could be geometricals.
Okay. That's
Okay.
all.
Okay.
Thank you, sir.
Welcome.
Doctor?
Yes, Gontang.
Yeah. If let's say in exams, let's say they
Exam.
say draw all the possible isomers for this specific.
Oh, for sure. This question is cannot come out. It's
No,
too
I'm just,
simple.
yeah. No, I mean like if should we give like geometrical or like positional?
Yeah, you can use geometrical also. Yes, but you have to state that one. For example, cis or trans, something like that.
All right.
Okay. Mm-hmm.
Okay. Thank you, doctor.
Don't worry. Okay. Any question before we finish? I guess today is quite short sessions. Half minutes, half hours, okay. So what's happened if we write the structure but wrong electron movement errors? Okay, it's wrong. Okay, Hidayah? No, no need to draw to write the name, no. Okay.
Doctor, are we required to draw all the
Lucas.
valence electron during the exam?
Can you repeat again, Lucas?
I mean, are we required to draw all the long tail or the valence
Oh, no,
electron?
no, no, no.
Just the
I just want to
structure, right?
guide you, based on my experience, most students wrongly draw the structures. I try to avoid this silly mistake, because if we find that kind of silly mistake, totally the answer is wrong. Like Hidayah asked during the in chat box, what's happened if we write the right structure but wrong electron movements? The answer is wrong. No half, okay? It's to make it easy for everybody, no half, no 0.5, no 0.2, 1.5, is not like that, okay? We just give you 1 or 0, that's all, okay?
Okay, thank you, doctor.
Yes, correct, Hidayah. It's safer. No, it's safer to draw the arrows. Sometimes our scheme shows the process how you can get structure from structure 1 to the resonance structure 2. It's better. Okay. It's kind of when you do mathematics, okay, and you have to show how you get the answer, right? So it's better to do that, okay? If during that time we have empathy for the student, we try to find the marks for you. Okay. Okay, any question before we finish?
Sir,
Yes, who is that?
I got a request.
Who is that?
It's me, Chan
Chan,
Jaden.
yes, Chan, yes.
Can we ask for more questions? Like exercises?
You want to ask more questions?
Yeah, I mean exercises on this chapter 1.
You can do by yourself, and it's better to have one-to-one.
Okay.
Okay, Chan?
Okay.
Okay, it's better to do that, because I will give a link and we discuss one-to-one. Okay. Okay, so I think thank you for today. So we already finished chapter 1. Okay, so if you have a book, okay, if you have a book, this book, okay, you can answer all the questions from this book. Okay, there is a lot of questions. I guess there is more than 80 questions. It's kind of exercise for you, so you have to do by yourself. And please contact me if you need the answer or discussion about this one. It's better to have discussions or make an appointment. We can meet. We can meet in my office, so we can have more further discussion about this one. Okay, maybe we can have a cup of tea or coffee. And for next Monday, I will please continue by doing self studies. Okay, I will upload the lecture notes and also record the lectures by Dr. Yang. So, and I also will provide you some questions that we can discuss on Wednesday. So Monday doesn't have any class, but you have to do your own exercise, learn about chapter 2. For me, it's better to do like that because we can save a lot of time. Okay. Yeah, oh, sorry, Hidayah. Okay, sir, is it wrong if we do not put the launch pad? Yes. Okay. I skip draw the second mining for today. Is it? Okay, wait, I have a mirror punya questions. Wait, Amirul. Where is it? Question 6, okay. Second microcote is escape flow. Yeah, you can do that, but doesn't have any mark for you. Okay. Can I say answer for question 10? Yes, okay. This one? Hidayah? Okay. So, do we have tutorial session? Yes, we will have tutorial sessions. Next week will be registrations for tutorial sessions. The Taiwan will be briefing it. And I think on the third week, we will start the tutorial. Okay, probably online. Don't worry. I think that's all for today. Thank you very much. Stay safe, stay healthy. If you have any question, just text me.
Yes, come on, shorty, let's go. Girl, I see you over there in the corner of the dance floor, and I know you're acting shy, looking at the corner of your eyes. So I pick my heart up off the floor, move my feet closer to yours, catch my breath, and I say, I'm the one you're looking for. So come on, dance a little dance. Take my hand, darling, take a chance. You be my queen, I'll be your king. Show you everything that you've been missing, shorty. So come on, dance a little dance. Got me in a trance in just one glance. So don't wait no more. I'm the one you're looking for, shorty. Girl, I see you over there hesitating, deliberating. You keep me waiting on a sign, looking at the corner of your eyes. So I pick my feet up off the floor, move my hips closer to yours, catch my breath, and I say, I'm the one you're looking for. So come on, dance a little dance. Take my hand, darling, take a chance. You be my queen, I'll be your king. Show you everything that you've been missing, shorty. So come on, dance a little dance. Got me in a trance in just one glance. So don't wait no more. I'm the one you're looking for, shorty. I'll be the one you're looking for, shorty. So come on the dance floor and baby show me all your moves, all your grooves. Shorty, I got something to prove to you. So come on, take a little chance. Got me in a trance in just one glance. So don't wait no more. I'm the one you're looking for, shorty. So come on, dance a little dance, dance a little dance. Come on, dance a little dance. So come on, dance a little dance. Take my hand, darling, take a chance. You be my queen, I'll be your king. Show you everything that you've been missing, shorty. So come on, dance a little dance. Got me in a trance in just one glance. So